Welcome to question 3, and we've got some stuff on circuits. In the first one, we've got another multiple choice, and we need to know our circuit symbols for this. So I'll go through 4 circuit symbols for you. Here we go. That one there. That is a diode. That's a component that only allows current to flow in one direction. It has a very, very high resistance in the other direction. So think of this as playing and this is stopping. So the idea of flow in a single direction. So that's not what we're looking for, because we're looking for a thermistor. If you see this symbol, it's kind of the symbol for resistor with a circle around. We've got the arrows. The arrows are indicating light. So that is an LDR, diode. We have an M, which stands for motor. And then last but not least, we have another type of resistor, a resistor that responds to changes in temperature, and that is our thermistor. Okay, sorted. So that was question 3A. Pedro showing us that we're doing question 3 now. Let's have a look at B. So in B, we have a table. Okay, so potential difference in volts, current, I should have stuck with symbols there. Anyway, current in amps and resistance in ohms. Okay, and essentially, we're going to have a look at, let's put a little bit of data here. What we've got is an example of, as we increase the potential difference, we're getting an increase in current, and an increase in resistance. But essentially this is a bit of a question about whether this process is going to be a linear one, so we need to think what's going to go in there. Now hopefully that kind of we could probably almost just guess what that is, but we need to do a calculation because in fact we've got a 3-mark question. Oh, sorry, I've gone off the page here. There we go. We've got a 3-mark question, and it says that we need to fill in this missing value. So we are going to use potential difference, V equals current times resistance. We're going to rearrange that like so. And that is, we're going to substitute in this value and this value, so 5.0 over 0.26. Let's grab my calculator again. We've got to try and avoid the glare from the light. 5.0 divided by 0.26, and that gives us 19.2. We're going to stick with the 2 significant figures as I've been doing. Remember, you won't lose marks at GCSE unless it specifically says that you need to leave a certain number of significant figures, but I'm going to do it as we should with 2 significant figures there, so that's 19, and that would be the missing value in there, which we could have guessed, but you're going to need to do the calculation in order to get all 3 marks. Okay. We're then given a conclusion. The conclusion is that the resistance is directly proportional to potential difference. It's the idea of resistance being directly proportional to potential difference. Now, what we need to remember is that if we were to draw a graph of something that was directly proportional, what would we get? We would get a straight line. Okay, as one thing doubles, so does the other thing. So you might know from maths, for example, that if it was directly proportional, potential difference was directly proportional to the resistance, then we would have something like this: a constant, potential difference equals a constant times R, and that would show us that we had a directly proportional relationship. Now, what we can do here is, well, we've got a 3-mark question, and we essentially need to say whether the relationship is directly proportional by looking at the data that we had earlier. So what we'll do is we'll take a bit of data. For example, let's take this bit of data, let's double potential difference and see what happens to the resistance. So first of all, we're going to say as potential difference, a little bit out of focus there, as potential difference increases, resistance increases. So one goes up, so does the other. However, there is not a doubling in this example, and what we want to do is make sure that we're demonstrating that that's the case, or that's not the case. Okay, so doubling, I'm just going to simplify to PD here. Doubling PD does not double resistance. Sorry, I don't know, English teachers look away, sort of going between capitals and lowercase, apologies. So doubling PD does not double resistance. And then we're going to take an example. 2 times 2 is 4. That's our potential difference from up here. 14 times 2 does not, definitely does not equal 18, which is what, you know, if it was going to be doubling, it would equal 28, and it doesn't. It equals 18. So just doing a calculation to demonstrate that we're not getting a doubling of resistance. You know, that's the way you might feel like you want to do it. I mean, technically you might come back to this idea of a constant and there not being a constant, so this value isn't supported by the data, but taking an example and showing that it doesn't double is a perfectly acceptable way to do it. That's your next 9 marks, and that is question 3 completed. Not much Pedro, but he's going to make an appearance in the next one.